morning, everyone. My name is Dr. M. Nagaraju, working as Assistant Professor in the Department of CA and ML in Institute of Aeronautical Engineering, Hyderabad. So today, in this particular session, we are going to discuss about a concept called as constraint satisfaction in artificial intelligence and expert systems. So the topic we are going to study during this one is called as constraint satisfaction, or otherwise we can say it as a constraint satisfaction problem. In this particular thing, we are going to see different components, what we are going to use in solving the constraint satisfaction problems, and what are the different types of constraints we are having, and how we make use of those constraint satisfaction components in order to solve particular problems. So let us directly move into the concepts. So till now, we have seen different kinds of techniques like informed search techniques and uninformed search techniques in order to solve certain kind of problems. But means during the time of solving the problems, either by using informed search or uninformed search, we might have used one particular word which is called as state space. Means in order to explore, what we can say is state space is nothing but the way where we are exploring the solution to a particular problem. Means, for example, if it is a search kind of problem, generally what happens, a given state, a state will be given to us and we will be asked to go to a desired state. Means the given state will be called as the initial state, and the desired state will be called as a goal state. Means whatever the paths we are exploring from the given state to the desired state will be considered as a state space. Means state space is the most common way of representing how we are exploring the problem into solution in different ways. In informed search technique or uninformed search technique, we might have used the same concept called as the state space or the state space representation. During the time of state space representation, we might have used tree representations for some kind of problems, or we might have used graphical representations for some kind of problems. Graph representations or tree representations means the exploring of the problem to a solution. How we are exploring the things from moving from problem statement to the solution. It is represented in a different ways, like in the form of a tree or in the form of a graph. But actually what happened, there will be certain kind of problems which are not exactly matches with the representation of a tree, or representing the problem in the form of problem and the solution in the form of a graph will not work for us. So in that case, we are going to work with another concept called as constraint satisfaction, or otherwise we say that these kind of problems comes under constraint satisfaction problems. So during this particular video, we are going to discuss more detail about this constraint satisfaction and also the constraint satisfaction problems with two examples. So just now I have discussed that the way how we have represented or the way how we have solved the other kinds of problems is we can say, for example, if it is a search kind of problem, whether we have used informed search technique or we have used uninformed search technique, generally what happens, we might have come across different stages where it will clearly shows us how we have transformed from the given state to the desired state, or from the initial state to the goal state. But in that particular case, what happened, there will be a state given to us. For example, we can consider that it is an initial state. To this particular instance, initial state, what we do is we will try to apply certain kind of rules or certain kind of operations. Means whenever we apply an appropriate rule or an appropriate operation to the initial state, it will make us some kind of motion. So what that motion will do is it will allows us, or it will make us in the sense it will make the AI machine or AI agent to move from the initial state to the other state, which will be considered as a new state. So while solving a particular problem, such kind of problems, the AI agent, whenever he is in the initial state, will try to apply certain kind of operations, and he will try to move to the other state so that he can, at the end, he can reach to the goal state. So this is the thing that generally happens. Means until and unless the AI agent applies the appropriate rule to the given state, he will not move to the other states. So this is the kind of thing what we have seen in the earlier problem solving. But today we are going to see a different problem solving mechanisms. In that we call it as a constraint satisfaction. So what do you mean by this constraint satisfaction? Means here, in place of the set of operations or the set of rules, we are going to see some kind of constraints. So constraints, in the sense, they are nothing but some kind of rules or some kind of conditions, we can say. Means the change in the position of the AI agent can happen only when he solves a particular condition, or when he satisfies a particular condition. Means instead of applying certain kind of rules, or instead of applying certain using certain kind of operations, here we are going to apply certain kind of conditions. Means until and unless the AI agent satisfies that condition, then only it will makes the AI agent to move to the next state. So we can take a very general example to understand how this constant satisfaction will be. For example, when you are traveling in the national highway, until and unless you pay the toll fees, you will not be allowed to move further. Means what happens here, the traveling of a person completely depends upon the payment of the toll fees only. In the similar fashion, here payment of the toll fees is nothing but a kind of a condition. Means until and unless the person pays the toll gate, he will not be allowed to travel further in the national highways. In the similar fashion, until and unless the AI agent or the program satisfies the certain conditions, then only it will allow us to move to the next state. So that's why these kind of problems, generally we call it as a constant satisfaction problems. So coming to the definitions, it is very clear. By the name itself, we will come to know that these kind of problems are nothing but solving a problem under certain constraints or rules. Means there will be rules everywhere. We can say there will be certain kind of rules, or there will be certain kind of conditions, and it can be a single condition, or it can be multiple conditions. Until and unless we satisfy the condition or conditions, then only there will be a change in the position of the AI agent. So it will be like that. That's why we say that then by the name itself, the constant satisfaction problem is nothing but solving the problem under certain constraints or rules. So in simple words, we can redefine the definition in this particular way also. So constant satisfaction is a technique where a problem is solved when its values satisfy certain constraints or rules of the problem. So just now we discussed, while traveling in the national highway, until and unless we pay the toll fees. Here paying of toll fees is nothing but here satisfying certain kind of constraints. So whenever such kind of constraints are satisfied, or whenever a particular rules are applied to it, means when it satisfies that particular rules or constraints or conditions, we can say, then we can say that this is the way of solving a particular problem. Means not only applying certain kind of rules, not only selecting appropriate operations, but also you can solve the problems even by satisfying certain kind of constraints also. So in simple words, we can understand that constraints is nothing but the condition. Okay, so for a particular situation, it can be a single condition applicable, or there may be multiple conditions applicable there. So that depends upon the complete problem statements. So such type of technique generally will leads to the deeper understanding of the problem. So what happens for deeper understanding of the problem, this is very, very important. Why? Because from our first module onwards, we are discussing that knowledge base is very, very important to solve any kind of AI related problems. So until and unless you have a large quantity and good quality of knowledge, you cannot supposed to make use of it and make the AI machine to work intelligent. So for that one, what happens, in order to understand the problem statement more clearly or more in depth, so these kind of techniques will help us in doing that. That's why we are saying that it will makes us for deeper understanding of a particular problem, and as well as we will try to get what is the complexity that exists in that particular problem. Okay, so in simple words, we can say that constant satisfaction is one of the technique which will makes the programmer, or which will makes us in order to understand the problem statement more clearly, more deeper, and also to understand what complexity that exists in that problem statement. So why? Because if we could able to clearly understand the problem statement, then it will be very easy to apply a appropriate rule or appropriate technique, and we can solve it. So constant satisfaction is more important, where we are going to make use of it, where we didn't use these kind of techniques to solve the problems. Here we need to understand what are such kind of problems, or what are those kind of AI problems where generally we apply this constant satisfaction. So for that one, we say that there are some examples. Means in this particular video, we are going to see certain kind of examples where we are going to explain more clearly why these problems are considered to be the constant satisfaction problems. So we can say that most of the AI related problems, okay, most of the AI related problems, they will be considered as a problem of constraint satisfaction itself. So in this particular thing, what we do is we are having a particular goal. Okay, we are having a particular goal in the sense in order to discover the problem state that satisfies a given set of constraints. So that is very very important. Means it is a problem in which the goal is to discover some problem state. It does not mean that we are going to get the solution. Okay, but it will allows us to move towards the solution. That is important point here. Okay, that's why we are making this particular statement saying that our goal of using this constraint satisfaction technique is to discover some problem state. So what this problem state will tell us to us means we are moving towards the solution. So the main advantage. So what is the advantage of making use of these kind of things? Means what is the advantage that we are having whenever you are using this kind of constraint satisfaction? So the biggest advantage is we are going to see the reduction in the time period what we are using to perform the search activity. So we can clearly do a comparison. Means by using this informed search techniques and uninformed search techniques, how much time we are taking to perform a search activity. To that, if you compare it with the constraint satisfaction, clearly we can say that by using this constraint satisfaction, we can reduce. Means it will allows us to reduce the time that is taken to perform the search activity when compared with the other methods, just like informed search techniques and uninformed search techniques. Coming to the examples, right? Just now we are making a lot of discussion about this constraint satisfaction, satisfaction, and what we should supposed to know what kind of problems are considered to be the constraint satisfaction problems. For example, we can consider these things as a constraint satisfaction problems. Means a cryptarithmetic puzzles, in the sense Sudoku programs or color filling program problems, they comes under this constraint satisfaction problem only. Okay, let us try to understand more clearly. Think that if we talk about this Sudoku problem itself, we know that we know that it is a board which is going to have 3 by 3 boxes. Okay, all of 9. Okay, means there will be a 3 by 3 boxes. How many number it is going to have? 9 boxes we are going to see. So for example, if it is one of the box, if it is one of the portion in the Sudoku problem, generally we know what we have to do is here in this game playing, in this problem we say that we need to arrange the numbers from 1 to 9. We need to arrange the numbers 1 to 9. For example, if I keep 1 here, then what happens? What is the next number I should keep here? So that completely depends upon the constraints. So what is that constraint? So means whenever I keep 1 in this particular box, that means that no one should be repeated either in this particular area or in this or in this. Means in any of the direction, if you see, it should not repeat 1. So this is called as a constraint satisfaction. Means when can I keep 1 in this particular position? Means in these particular boxes there should not be 1 before. In these particular boxes and in these particular boxes there should not be 1. Okay, so here what is happening, whenever I am trying to place a particular number in a specific box, it is not allowing me directly to do that. Means before inserting, I should supposed to satisfy some of the constraints. What is that? The number should not be repeated in these particular directions. Okay, so like that it will be in the Sudoku problem, and we are going to clearly see this color filling problem in detail in the coming slides. Okay, so for simple understanding, we can say that constraint satisfaction problems are going to solve certain kind of problems by resolving certain kind of constraints which are applicable to that particular state. Okay, so let us try to understand we will try to understand what are the requirements that we need in order to handle these constraint satisfaction problems. So the first requirement what we need is the state space and also the notation of the solution. Okay, so we are going to see these things in detail in the components of the constraint satisfaction. So what are the different components we are going to consider? So in simple understanding, we can say that we are going to see certain kind of variables. We are calling them as the components of the constraint satisfaction problem. Variables, we are going to see domains. We are going to see certain kind of rules rules, or otherwise we can say a certain kind of constraints. Okay, so these are the three main important elements or three main components what we are going to work with these constant satisfaction problems. So let us try to understand what do you mean by this state space first. So a state space can be defined as the assignment of the variable values to the variables. So if you think that there are certain kind of variables, so what are the values you are assigning to that particular variables, that is going to talk by the state space. Okay, we need to try to understand the difference between state space and state space representation. State space representation is a graphical representation, means we are in pictorially we are showing that we are showing how we are exploring the problem to the solution state. But whenever we say it is a state space, we are going to see certain kind of elements. So in this particular constant satisfaction problem, we say that if it is a state space, in this state space, if I say it is a state, that means that we are going to talk about the values whatever we are assigning to the variables. Okay, right? Let us try to understand more clearly about this. Okay, assignment of variables. First, we will try to talk about the assignment of variables. So there are three different ways we can say. There are three different ways how we can apply the values to the variables. Okay. So one way is called as consistent or legal assignment. Consistent or legal assignment, which means that an assignment which does not violate any constraint or rule. Means whenever you are assigning a particular value to a variable, that should not disturb the constraint. Means it definitely should satisfy the constraint. Then only we say that it is a consistent or legal assignment. At the same time, if I say it is a complete assignment, that means that where every variable is assigned with a value. How many number of variables we are considering for that problem? For all those number of variables, we are assigning the problems. Sorry, we are assigning some values. Then we say that it is a complete assignment. But we need to remember that the assignment of variables in any of the case should not disturb the constraint. Means it must satisfy the constraints. Then only we will allow. Otherwise, such kind of assignment will not be allowed. I will take one simple example here. For example, think that there is a equal to 1 and b equal to 1. So if there is any constraint saying that a not equal to b, then I should not supposed to take like this. Why? Because it is the assignment of 1 to a, the assignment of 1 to b is not satisfying this particular constraint. So what does it mean? Means the assignment of 1 to a and b is not allowable. This kind of assignment should not happen. It will be like that. Means whether you are working with consistent assignment or whether you are working with complete assignment, whether you are working with partial assignment, it does not matter. But you should supposed to satisfy the constraints. Okay. So, and the third kind of assignment is called as here the partial assignment. The assignment which assigns values to some of the variables only. Means we are not going to consider all the variables. Only to few particular variables we are going to assign certain values. Okay. So these are the three different ways how we can assign the values to the variables what we have considered during these problems. Okay. So we will try to see examples. Means we are going to see certain examples where we are going to clearly understand what do you mean by this partial assignment, what do you mean by this complete assignment, and everything. Let us talk to the other component of the constraint satisfaction, which is called as a domain. So even these domains are going to be two different types. So one domain can talk about it can be an infinite domain or it can be a finite domain. If I say it is a discrete domain, then it means that it is a infinite domain. So what does it mean? Infinite domain means which we have one state for multiple variables. We are going to have one state for multiple variables. In that case, we say that it is a discrete domain. Okay, for example, a start state can be allocated infinite times for each variable. Okay, for that means that any number of times you can assign the start position to any of the variable. Okay, we can call them as a discrete domain. So whenever I say it is a finite domain, that means that we are going to have continuous states. We are going to have continuous states describing one domain for specific variable. One domain for specific variable. Then Such kind of things even we can call it as a continuous domain. Okay, discrete domain where we are going to see the infinite domain. We are going to have only one state with multiple variables. Whenever I say it is a finite domain, we are going to have, means we are going to see continuous states which are going to describe about the specific variable as well as a specific domain. But those we are calling it as a even the continuous domain also. Let us try to understand more clearly about these things. Unary constraints. So now let us talk about the different types of constraints what we are having. One is called as unary constraints, the binary constraints, and another one is the global constraints. So it is unary constraints is a simple type of constraints that restricts the value of a single variable. The name itself will say that unary. Whenever I say it is unary, only one value. Only one variable. If I say binary constraint, so we talk about multiple variables. For example, if I say that x2 is the binary constant, that means that x2 will be in between x1 and x3. At the same time, if I say it is a global constraint which involves the arbitrary number of variables. Okay, so any number of variables you can take, means the sequence you can take, or otherwise you can take randomly also. But there is no problem. Then in that case, we say it as a global constraints. Unary constraints where we talk about only one single variable. Binary constraints where we are going to talk about multiple variables, means two variables, and global constraints in the sense where we are going to talk about more number of variables. Now let us try to understand the representations. How, means theoretically we came to know that what do you mean by constraint satisfaction and how this constraint satisfaction problem will be. But in the real time cases, how we are going to represent this constraint satisfaction problem is more important. So just now we discussed that there are different components or different elements where we are going to see in this constraint satisfaction problem. So we can say that there are three main important components. So one component is about the variables, one component is domain, and another component is constraints. So what do you mean by variables? Means it is, you try to understand, it is a finite set. Finite set in the sense it should be limited number, means it can be any, but it should not be infinite. So here the number of variables you can consider is finite, and at the same time the domain also you can consider finite. Domain. So what this domain talks about means the different types of values that a particular variable can take. What are the different set of values that a particular variable can take? So this kind of thing will be explained by the domain. So what happens is here, for each and every variable we are going to have some set of domains. For example, if there is v1 variable is there. For this variable v1 variable, there may be multiple domains. d1 and d2 domains may there. So these d1 variables may have certain kind of values, and at the same time this d2 may have certain kind of values, some set of values. Means whenever you are assigning values to v1, you should suppose to consider only the values that we have represented in these domains. It will be like that. Okay, so for a constraint satisfaction problems, we are going to consider the finite number of variables, at the same time finite number of domains. And coming to the constraint, how we are going to frame the constraint, or how we are going to represent the constraint, means in the mathematical form we represent it as Ci equal to, in the bracket there will be two parameters, one is called as scope and another one is called as a relation. These two parameters are required to frame a constraint. So how we are going to see, if I say it is a scope, it means that it is a set of variables that participate in the constraint. Means whenever you are framing certain constraint or a condition, what are the variables you are considering? That set of variables are represented by the parameter called as scope here. At the same time, if I say relation, it is going to define the relationship between the define the values that variables can take. So what kind of values that particular variable can take? So it is going to talk about the relation. Just now we said here, if we are talking about this v1 variable, if it is related to d1 and d2, and v1 can take only 1, 2 or 2, 4. So who is going to decide these things? Means by using this relation. I am repeating once again, whenever I say it is a constraint satisfaction problem, it is going to have two parameters. One is scope and another one is relation. The scope is going to talk about the set of variables which are participating in framing that constraint, and the relation is going to define the values that variables can take. Let us try to understand more clearly with an example. Think that there are three constraints. So these constraints we represent it as C1, C2 and C3. And think that there are two variables V1 and V2 for each constraint with the domains A and B. Okay, so how we are going to represent the first constraint? C1 is the first constraint. So what this V1 and V2 talks about? The scope. Means the set of variables that are participating in framing this constraint. V1 and V2 are the set of variables here. And the next parameter is the relation. Okay, so what is a relation? Relation, it is some kind of condition. What is that? V1 should not be equal to V2. So this is a condition what we have. And we are framing the another way. What is that? If V1 and V2 are the participants, scope, and A comma B indicates the domains, to which domains this particular variables belongs to. Coming to the C1. So in the C1, what we are doing is we are framing the things V1 comma V2 comma. So what does it mean? For example, think that there is C1 constraint is there. This C1 constraint belongs to two particular domains, means it can take the values from two particular domains. And the first domain A is having the possibility of taking 1, 2 values, and from B domain there is a possibility of taking the values 2, 4. So now what we have to do is we came to know what are the variables that are participating and also the relationship. What is that relationship? V1 should not be equal to V2. So by taking these two considerations, we should suppose to frame the C1 constraint. So how we do it? Means this is the first case. Means here we are framing the assignment of values to the variable. What is that? First it is 1, 2. So what do you mean by 1, 2? Means I am taking one value from the A domain and one value from the B domain. So what we have done, we have made it as 1, 2. Now the question is not just taking the values, but also you should suppose to see whether is there any problem with this particular constraint. So what is that? V1 should not be equal to V2. So 1, 2 are not at all equal. So that means that we are not denying the condition what we have. In the similar fashion, we are taking one value from A and another value from B domain. So what happens? The other possibility what we are having for assignment is 1, 4. At the same time, it is 2, 4. I should not suppose to take 1, 1. Why? I should not suppose to take 2, 2. One value from A domain and another value from the B domain. Why? Because of course taking the values is okay, but whenever you compare these two with this particular constant, that is V1 should not be equal to V2. So in that case, what happened? This assignment is not satisfying the constant. It is not satisfying the condition. So you should not suppose to assign these kind of values to the variables. So this is the way. That means that for this particular example, the possible values what we can assign to that particular constraint is either you can go for 1, 2, or you can go for 1, 4, or you can go for 2, 4. It will be like that. Let us try to understand this constraint satisfaction problem more clearly by using this example. So this example is talking about the color filling problem. So in the examples only, we have discussed that there are two kinds of problems we can solve by using this constraint satisfaction. One is Sudoku problem and another one is this color filling problem. So we are talking about the color filling problem here. So what are the three elements we require? One is the number of variables, okay, and also the domain and also the constraints. So what are the variables we are having? We are having three variables, 1, 2, 3 and 4. And what are the domains? Red, green and blue. Okay, so what this 1, 2, 3, 4 talks about means there are 4 circles in the given state space. Okay, this will become the state space. In this state space, there are 4 circles. So what we need to do is we need to fill up these circles with colors. So what colors you can take? You can take either red, you can take either green, and you can take either blue. But while filling the colors, there are certain kind of conditions for us. What is that conditions? 1 not equal to 2. So what does it mean? Means whatever the color you are filling in this one circle should not be same when you compared with the color in circle 2. So what does it mean? For example, if I fill this color, this circle with red color, I should not supposed to fill this 2 circle with red color. Why? Because 1 should not be equal to 2. This is the first constraint whatever given. And this, in the similar way, the second constraint is 1 should not be equal to 3. Means here, if you have filled this circle with red, so what happens here? You should not supposed to take red in this one. Why? Because 1 and 3 should not be equal. In the similar way, as you have taken red color to fill this particular circle 1, then you should not supposed to take red for circle 4 also. Why? Because this condition is talking all about that. 2 should not be equal. Means the color you filled in second circle should not be same with the color that you are going to fill in the fourth circle. Similarly, 3 should not be equal to 4. In the similar fashion, you should supposed to understand. Now coming to the point, how we can solve by using these constraints, means how we can solve this color filling problem, means how can we solve the we can fill the colors so that it can satisfy all the constraints given to us. Okay, so let us try to understand. We will go in a particular sequence. So initially what happened, for everything there are 3 possibilities, means either you can fill the circles with red color, green color or blue color. So let us try to understand. First we are filling the first one with the red color. So think that this is the red color. This circle we have filled with red color. So based upon the conditions, 1 does not equal to 2. 1 should not be equal to 2. Means I should not fill the second circle with red, the third circle with red, and also the fourth circle with red. Okay. So that means what happens, for second circle I am having the possibility of filling with green color and blue color, green or blue color. In the similar way, for 3 and 4 also we are having the possibility to fill them with either green color or blue color. Okay. Now coming to the next point, so think that in circle 2 I have filled the green color. There will be no problem in this one. Why? Because 1 does not equals to 2. Here it is red and here it is green. So there will be no problem. So in that case, what happened, in first circle we are already having red, and in the second circle we have filled just now with the green color, and for third possibility we are having, means for third circle we are having the possibility to fill it with green color or blue color. Why it is green color or blue color? Why? Because here it is already red. Means you should not supposed to take red here. Why? Because 1 should not be equal to 3. This is the constraint. So the possibility. And coming to the fourth one, there is only one possibility. What is that? You can fill it with only blue color. Why? Because already in 1 it is red. Means you should not supposed to fill this circle with red color. In the similar way, in 2 already you have filled it with green color. You should not supposed to take green. Means red possibility is not there. Green filling possibility is also not there. So what is left? Only blue is left. Coming to the third step. In the third step, already we are having red in the first circle, green in the second circle, and think that in the third circle we have filled with the blue color. So that means that we have filled this circle with the blue color. So what happens here? So what is the color that I should supposed to take to fill this fourth circle? I should not supposed to take red. Why? Because red is already repeated here. I should not supposed to take green here. Why? Because green is repeated. 2 does not equal to 2. There is a constant here. 2 should not be equal to 4. Means already you filled this circle with green color, so you should not supposed to take green color in this circle. And here already B is there. But another constant, what is that? 3 should not be equal to 4. Means already blue is there in third circle, so you should not supposed to fill this fourth circle with blue color again. So what we have to do is we need to perform the backtracking. So backtracking in the sense, we are going to remove this. Why? Because this is not the correct way. You should not supposed to fill this circle with the blue color. Okay, so what we are doing, we are keeping it as empty. So this will represent the same thing. So what we are doing now, instead of filling this one with the blue color, we are filling the third circle with the green color. Okay, is it possible? Yes, it is possible. Why? Because there is no problem. We are not denying any of the constraint that present here, that is given here. So for example, here you see in blue we are having 2, means in the second circle we are having green, and in the third circle also we are having green. But we does not have any constraint saying that 2 should not be equal to 3. This kind of constraint is not there. So there is no problem even if you are filling this third circle with green color. So then what happens? We are having a possibility, means we will get a choice to fill this fourth circle with blue color. Means this is the way how we need to assign the colors to these particular circles by satisfying all the constants that are given here. Okay, so you need to understand one more important point here. Means during the time of solving these constant satisfaction problems, even you can make use of the most important technique, and the best technique is that is backtracking. Means backtracking is allowed where you can come back one step. Means you can perform the undo and you can come back to the come back and you can again you can move ahead by taking the other possibility. Means by assigning the other value. Okay, so this is the way how we need to understand how this constant satisfaction problem is going to solve the problem of color filling. Let us try to understand one more example and we will see more clearly about this concept called as backtracking. Means how backtracking is helping us in order to solve these constant satisfaction problems. Okay, so you try to understand there are three things given to us. One is three variables given to us, A, B and C, and each variable is having the possibility of taking the values 1, 2, 3 for all the three variables. So certain kind of constants also given to us. What is that constants? A should be always greater than B, and B and C should not be equal, and at the same time A and C should not be equal. So we need to understand how this backtracking will help us in order to assign the appropriate values to these particular variables. Let us start from here. Think that first I will make it as A equal to 1. Means I am starting with only one variable and I am assigning 1 to this A. So this kind of assignment is called as a partial assignment. So you try to understand, is it possible to assign 1 to A? Why? Because just even one can take one to A can take 1, 2, 3 values. I should not supposed to directly assign the value. So what I have to do means I need to check whether it is satisfying all these conditions given or not. Okay. So in this case, what happens if I say A equal to 1? So we are going to compare it with this condition. A should be greater than B, but we have not considered B variable so far. So you can ignore it. There is no problem. B does not equals to C. So till now we don't know what is B and what is C also. So you can ignore it. And at the same time, A should not be equal to C. We are talking about only A, but we didn't see C till now. So this kind of thing, there is no problem. We can assign value 1 to A. Now come back to the second one. A equal to 1 and I will take one more variable, B equal to 1. So backtracking, in the backtracking, we need to follow a proper sequence. So we are coming with the assignment of first value. So what happened? A equal to 1 already there and we are assigning 1 to B also. Now whether this is possible or not, that we need to see. So what happened? A should be greater than B. So the first constraint itself, it is not satisfying. So we should not supposed to ignore it. So what we need to do? We need to perform the backtracking. Backtracking of what? Backtracking means you should supposed to consider the other value for B. So in this case, what happens? It will become A equal to 1 and B equal to 2. Okay. So is it possible to assign 2 to B? That we need to see. A greater than B. A should be greater than B. Means even this is also not possible. So again you perform the backtrack. So how we perform the backtrack? We say that A equal to 1 and B equal to 3 in this case. Okay, so is it possible now? Still it is not possible. Why? Because it is also not satisfying the first constraint. It is also not solving the first constraint, that is A must be greater than B. So again we are performing the backtrack. So here we should not supposed to take 4 here. Why? Because only B can take 3 values, 3 domain, 1, 2 and 3. So what we need to do? We need to come up here. What is that? A equal to 2. And we talk about B equal to 1. Okay, so now you try to do it, whether this kind of assignment is possible or not. So when you take the first condition, what happened? A greater than B. A greater than B. So what happens here? 2 is greater than 1. So the first condition is satisfied. Coming to the second one, B should not be equal to C. Okay, B value is 1 we have assigned, but we didn't come across C till now. So we can ignore it. A should not be equal to C. this is also we can ignore, means this is satisfied. This is satisfied. At the same time, you can take one more possibility also. So I will take 2, I will take b equal to 1, and at the same time I will take c equal to 1 also. We will see whether it is possible or not. So in this case, what happens? A is greater than b, a should be greater than b, 2 is greater than 1 only, so this is fine. B should not equal to c. But what happened here? B equal to 1 and c equal to 1. Means the second condition is not satisfied. So you close it. So what happens? You should suppose to go for backtracking. What is that backtracking? I can go for other possibility. A equal to 2, b equal to 1, and at the same time c equal to 2 I will take. Again the same thing. The first constraint is already satisfied. A is greater than b only. And second one, b should not be equal to c. So b and c are not same. B is 1 and c is 2. But what about the third constraint? A should not be equal to c. But a value is 2 here, and also b value is also 2. Means this is also not allowed. So what we do? We will do the backtracking. So at the end, what happens? It will become a equal to 2, b equal to 1, and c equal to 3. We will try to see whether this assignment will satisfy all the conditions or not. A greater than b, it is true. B does not equal to c, it is true. And a and c should not be same. They should not be equal. Means in this particular case also it is true. Means this assignment is also possible. Like this, we should suppose to explore all the possibilities where we can assign different values to the variables. Okay, so this is the way how the backtracking mechanism will help us to understand or to explore the different possibilities of assigning the values to the variables. Okay. So this is all about the constraint satisfaction and constraints, how we can solve the constraint satisfaction problems. So these are the references what I have used in order to prepare this particular content. Hope you understood, and we will come up with other topic in the next session. Till now, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.